Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Here you can find other interesting subjects as well along with the engineering drawing. Do subscribe the channel to get alerts. If you like this lecture, please hit the like button. Now, let's go into the topic, projections of plane surfaces. Let's take a simple plane. A lamina means it's a two-dimensional object only, but of a very negligible thickness. Call it as a lamina. A triangular lamina of 50 mm edges lying in HP, having one of its edges perpendicular to VP. So that is the position. That means when it is lying in HP, we see the actual shape in the top view. So wherever you see in the front view or top view, we have to draw that first. So here we draw the top view. This is the actual triangular lamina. This is the surface. And here, because the true shape is visible in the top view, we start drawing the top view. And here the one edge is perpendicular to VP, that is reference line, and having one of its edges perpendicular to VP. That's the thing. Now, coming to the projections, take the reference line and draw the top view first. Having one edge perpendicular to VP, equilateral triangle is drawn. Show the dimension 50 mm. And now mark the corners A, B, C. The corners are named here. And draw projectors from these points, all the points. Okay. So take the extreme points here to extreme projectors. And now highlight this point from here to here. Because it is lying in HP, the front view is seen on the reference line. So mark these points, corresponding points in the front view. A dash, B dash, C dash. Here C is put in brackets and as well A and B are open. Why it is kept in brackets means when you are looking at it from the front view, that is in this direction, A is nearer to the observer and C is away from the observer. Okay. Whatever the points which are visible to the observer are written openly, and the points which are outside, other side of the observer are put in brackets, which are invisible actually. So this is the common notion we have to follow. So these are the projections of the plane surface, triangular plane. Okay. Next. Let's take another triangular lamina, 50 mm edges, parallel to VP. That means the plane is like this. In the front view, we see the true length, actual shape of the object. Having one of its edges perpendicular to HP. One edge is taken perpendicular to the horizontal plane. So let's draw the projections. Take the reference line and draw the front view because it is in the parallel to VP, we see its true shape in the front view. So draw the triangle in the front view, show the dimensioning. Okay. Name the corners here like A, B, C. It's up to you whether you start this A as here and B here. It's up to you. But generally we follow one notation starting from this. Suppose I have started here A, B, C in the anti-clockwise direction. Suppose if you start here A dash and you want to follow clockwise, it's up to you. So A, B, C, that will be the naming. So name A, B, C here and draw projectors from all the points. Because the plane is parallel to VP, we have taken some distance in front of VP. The distance is not mentioned, so we can take some convenient distance and draw the extreme points here of extreme generators. Join a line here, and that is the top view. So mark corresponding points in the top view. A dash, B dash, C dash. So here, A dash, A like this. Okay. So because it is C dash, C, the top view points are marked A, B, C, simple points. Coming to this, when you are looking from the top, the points are C and B are nearer to the observer and are visible to the observer. So they are open and A is away from the observer. When you are looking from the top here like this, thus A is away from the observer, so A is kept in brackets. That is the notion. Now, let's take another plane. A square lamina, it's a four-sided lamina, plane surface. Sides are given, 50 mm sides, lying in HP like this, having two of its edges parallel or two edges perpendicular, both are same. These two are parallel to VP or these two are perpendicular to VP. To VP, draw its projections. So this is the plane surface. Now let us draw the projections. Because its a true shape is visible in the top view, let's start in the top view. Draw the square here by taking two edges parallel to the reference line or two edges perpendicular to the reference line. So the square is drawn. Now show the dimensioning here and draw projectors from all the points. Mark these points A, B, C, D. Draw projectors and highlight this from here to here and end to end. Mark the corresponding front view points A dash, B dash, C dash, D dash. C and D are kept in brackets because they are away from the observer. Observer is looking from this side, away from the observer. So C, D are in brackets. Now, let's take another one. A square lamina of 50 mm sides is parallel to VP, okay, parallel to the vertical plane and having two edges parallel or perpendicular to HP, right? These two are parallel to HP or these two are perpendicular to the horizontal plane, reference line. So this is the plane surface. Let's draw its projections. Take the reference line and front view is drawn because the true shape is visible in the front view. Mark the points here, A, B, C, D, that is A dash, B dash, C dash, D dash, and show the dimensioning. Draw projectors from the points here, and because the plane is parallel to the VP, take it at a distance from VP. Now, this is the top view, a line, straight line. Now, mark the points here, A, B, C, D. A and B, when you are looking from the top, A, B are away from the observer, so they are kept in brackets. These are the projections of the square lamina. Next, a square lamina of 50 mm sides is resting on HP, all its edges like this. Okay, it is on HP, that's why front view is on the reference line. All edges are making equal inclinations with VP. That means this edge, all this one, this one, this one are making 45 degrees angle with the vertical plane. So this is the position. Let's draw its projections. Take the reference line, XY, and draw the top view by taking one edge at 45 degrees angle. This edge is taken at 45 degrees angle. Automatically, all other edges will be at 45 degrees angle. So, show the dimensioning. Mark the points here, corners A, B, C, D, right? And draw projectors from all the points to get the front view. And from one end to the other, you can highlight it because it is the front view. It is a line in the front view. Mark corresponding points in the front view. A, A dash, B, B dash, C, C dash, D, D dash. Only D is away from the observer here looking in this side. So D is kept in brackets. Okay. So these are the projections of the square lamina. Next. So let us see some more plane surfaces in the next one. Hope you had understood this very well. If you have any questions, do comment, do like, share and comment. Thank you.